Okay, we get a quadratic to solve now. And normally with quadratics we would dive right in and start doing decomposition or some other factoring trick, but this one has kind of distracting coefficients. Two of them are fractions. In fact, I'm going to treat this one like a fraction also. And we should probably deal with the coefficients before we do anything else. We can get a common denominator for these coefficients easily enough. Two of them are already thirds, so it's just a matter of tripling this last one, top and bottom, to make it thirds also. So with that adjustment made, we have minus 4 thirds x squared plus 14 thirds x, no changes there, plus 30 thirds equals 0. Okay, so are there any common factors for this? Clearly there's one. We can factor out 1/3. Let's just take care of that. It is possible to take out more at this stage once you have enough experience, but for now this will be good. If we take out the 1/3, just eliminating this part, we're left with minus 4x squared for our first term, and 14x plus 30 equals 0. So you can think of this as all of these are divided by 3 because there's a 1/3 out front, or if you prefer, you can say we've divided each of these terms by 1/3, which is the same as multiplying them by 3, and that's why all these denominators got cancelled here. So this is better. This is looking more like a proper quadratic. Can we take any more out? Yeah, all of these coefficients are even, so we can take out a 2. And another thing I would recommend, because our leading coefficient is negative, take out a -2. Positive leading coefficient, there's some small benefits to having that. If we take out a -2 from what's in here, we get negative 4x squared divided by -2. We get 14x divided by -2. And 30 divided by -2. So there's... Okay, that's getting better all the time. 1/3 times -2, I'll just condense that into minus 2/3. Now, this quadratic, can we simplify that at all? If you use some kind of guess and check method, then go ahead and have at it. I'm going to use decomposition here, which means I'm going to leave the 2x squared alone, and I'm going to leave the 15 alone, -15. And for the middle term, I'm going to try to find two numbers which add up to -7 and multiply to the product of these, so -30. And I believe those numbers are -10 and +3. So instead of -7x, I'm going to say -10x plus 3x. And if you're doing decomposition, what you do next is factor this by grouping. So we'll factor what we can out of those two terms, factor what we can out of these two terms. And if things go well, we'll get a common factor out of that. From the first two terms, I can take out a 2x, which leaves me with x minus 5. From the next two terms, I can take out 3, which leaves me with x minus 5, and all that equals 0. Here's our common factor. If you've done decomposition successfully, this will always happen. If this doesn't happen, go back and check your work. This means I can take out x minus 5. What we're left with here is we have our minus 2/3 just sitting there. I'm taking out x minus 5, and with the x minus 5s removed, what are we left with? 2x plus 3. That's our other factor. 2x plus 3. And all that equals 0. So that's our factored form, which means we're nearly done. Now, just to finish this, the zero product theorem says, when you have an expression factored like this and it equals 0, you can solve each of the factors separately. So there are three possibilities for this equation. We can have either minus 2/3 equals 0, or we can have x minus 5 equals 0, or we can have 2x plus 3 equals 0. Now let's look at these one at a time. The first one is worthless. Minus 2/3 equals 0 is impossible. Minus 2/3 and 0 are totally different numbers. There's no variables I can tweak to make this true, so this doesn't produce any solutions. And in fact, if you have a constant in one of these zero products, it generally isn't worth looking at. It's only the ones with variables in them that are actually going to generate solutions, so really our attention belongs on these two. This one's easy enough. You add 5 to each side of it, and you get x equals 5, so there's one solution. And for the other, subtract 3 from each side, cut both sides in half, and there's another solution, minus 3 over 2, or minus 1.5. So because this was quadratic, we knew we might end up with up to 2 solutions, and sure enough, we did.